Welcome to an introduction to photovoltaics, brought to you by the Sun Academy online training website and the Solar Academy International based in Ontario, Canada. We are really glad that you have joined us on this journey to understand the solar industry. This short presentation is part 2 of a 2-part video presentation of approximately 20 minutes and gives you a flavor and overview of what to expect if you complete the 5-day course in solar PV design and installation offered by Solar Academy International. If you cannot attend our training school in Ontario, Canada, then continue with our online training program. An important part of any work you do at home or on a job site is safety. Safety first is the motto. We adhere to this and hope you do too. Work safely and at the end of the day go home to the ones who love you. The two biggest hazards doing solar installations are working at heights that are heights above 6 feet and electrical shock. Our courses will introduce you to the measures that you need to take to enjoy a long career in the PV industry. In order to understand solar photovoltaics, you will learn about Ohm's law, a simple mathematical equation that explains how electricity works. Do not be scared off by this. It's basic mathematics and easy to remember. You will also learn about Watt's power law that explains how power is generated in electrical systems. Again, do not be scared off by their mathematics. It's basic and easy to understand. You will learn about basic electrical circuits and their applications to PV systems. The two key types of circuits are series and parallel circuits, which, when combined in various patterns, create the desired voltage and power to run our electrical systems. In our course, you will learn about the sun and the fundamental properties that affect the design and installation of solar systems. In the summer months, most of eastern US averages 5 or more peak sun hours per day on south-facing surfaces tilted at local latitude, while the central and southwestern US averages 6 or more peak sun hours per day. We teach you how to interpret the data for all places around the world and how it affects your design and where to access the solar data. Seasons affect PV systems, and it is important to know what the best methods are to maximize the sun's energy and how to minimize the effects of seasons. You will learn how to determine where the sun is and how it affects your PV system. An important part of the design process is the site survey and the steps to achieve a successful outcome. A number of factors need to be considered when locating suitable areas for installing PV arrays. Many pieces of equipment are needed to complete a site survey. See if you can identify all the items in this picture. One of the tools is a solar pathfinder, which determines the shading in any location. Solar shading calculators require orientating due south depending on the hemisphere you are in, leveling and locating at the appropriate solar system height prior to making shading measurements. The Solarmetric Sun Eye incorporates a digital camera to capture obstructions on the horizon and align with sun path charts stored in the software. Results are automatically generated in the software for display or may be downloaded and printed on a computer. There are many components in a PV system. The major system components are shown in the following diagram. Here you can see the PV modules and array, a combiner box, a DC disconnect, and AC disconnect, a utility service panel, and batteries. These are the basic components in a PV system. The electrical utility system consists of three provisional parts: generation, transmission, and distribution, collectively known as the grid. First generation PV modules typically used 36 series connected solar cells which produced a high enough voltage at high operating temperatures to charge nominal 12-volt batteries. Now, newer, larger modules have 60 or 72 or more series connected cells designed for high voltage applications with interactive inverters. Most listed modules today can be connected in series up to a maximum of 600 volts DC, and some allow configuration up to 1000 volts DC where permitted. Because the high energy production from PV arrays does not always coincide with when loads require energy, batteries are used in most standalone PV systems. A charge controller regulates battery charging current from a PV array and protects a battery from overcharging. Battery chargers operate from AC power and contain transformers, rectifiers, filters, and controls to produce suitable DC power for charging batteries. Battery chargers are commonly used in PV systems where an alternative AC power source is available to provide supplementary battery charging in addition to a PV array, such as an engine generator or the utility grid. Inverters convert DC power to AC power and are characterized by the DC power source that use PV array or battery, their power output, operating voltage, power quality, and efficiency. Inverters convert DC power to AC power and are characterized by the DC power source they use, either a PV array or a battery, their power output, their operating voltage, power quality, and efficiency. DC disconnects isolate different parts of the system for safety and maintenance. Combiner boxes link different parts of the solar system. Fuses are used as safety devices to prevent damage to the system. Different parts of the system require different wire sizes and types of wire. You will learn about different wiring methods, and several methods of grounding are used to provide equipment grounding for PV modules. There are also many types of ways to build arrays. Fixed tilt arrays are non-moving structures in fixed orientation. Some types of arrays have summer and winter settings and are adjustable. Some arrays are ground mounted, and some arrays are pole mounted and employ either fixed, adjustable, or use sun tracking systems. The current voltage or IV characteristic, commonly known as the IV curve, is the basic description of a photovoltaic cell, module, or array electrical performance. Every solar panel has an IV curve that needs to be understood to best utilize its characteristics. In order to compare solar modules, the standard test condition, STC, is the universal rating condition for PV modules and arrays and specifies a solar irradiance level of 1000 watts per meter squared, an air mass of 1.5, spectral distribution operating at 25 degrees cell temperature. Different principles apply to sizing interactive and standalone systems. The size of PV systems is determined by the amount of energy that is produced or the energy required by the electrical load. Since sizing also estimates energy production, It is also used as the basis for establishing the economic value of a PV system for comparison with alternative power supplies. The sizing process involves estimating the size and ratings of the PV array and other system components needed to meet the performance objectives. Most PV inverters record and display numerous errors, codes, and fault conditions associated with problems in both DC and AC circuits, such as DC ground faults in the array or out-of-range voltages on the array or utility service. Interpreting these codes and messages are a fundamental first step for any troubleshooting activities and help define specific problems and appropriate courses of action. Extensive details are provided in inverter manufacturer's installation instructions and operator manuals. Take the quiz number 2 to see if you got all the key points here, and if you want to learn more, sign up for the online courses or join us at the Canadian training courses. Thanks for watching. I hope you enjoyed the presentation. If you have any questions, please email us at the Sun Academy team at contact@sunacademy.com. Thank you.